Welcome back, everybody. This is going to be problem number 52 from the chapter 1 problem set. All right, so this is chapter 1, problem number 52, and this one's a little bit of a bugger. Nothing that you can't solve with the math knowledge that you already have. I'm going to tell you right up front. It's going to involve using the guess method. That is writing down your givens, your unknowns, and your equations, and being very deliberate and kind of meticulous about that. It's also going to involve some substitution, and that is some algebra substitution functions, and also it's going to involve the quadratic, so you're going to need to have your quad form program handy, okay? So what's happening right here? Well, we have really two scenarios of this car. All right, it says the car as you drive down a 1 mile stretch. All right, so there's 1 mile right there. So our distance, we'll call it distance 1 equals 1 mile. This is what we'll call scenario 1. All right, so you're in your car and you drive 1 mile. Okay, that's my terrible car, and it takes time t. So time in scenario 1 is, we're just going to call that t. We don't know what it is, but it takes a certain amount of time. Okay. We also know that you'll drive some velocity during scenario 1 right here. Why? Because that's what it's ultimately asking us for. It says at the very end of the problem. So what was your velocity what was your original velocity, it said. So velocity 1, we don't know. We're going to put a big old question mark right there. Okay. Let's compare that to scenario 2. All right, so that's, you're driving a mile at some amount of time and at some speed, okay? In scenario 2, it appears that you're driving a little bit faster. All right, so we got some motion marks right there. It's going to be number 2. We're driving faster because the velocity has increased. All right, velocity 2, that's a 2 right there. Sorry, in fact, let me erase it. Let me try that again. Velocity 2 is velocity 1 plus some change in velocity. Now you may be saying to yourself, well, wait a minute, we know what that change in velocity is. It's plus 7.9 miles per hour, right? And that's true. We are going to write that down in just a second, but for now we're going to use general terms. We're going to use general terms, okay? So we can describe our velocity 2 in scenario 2 as being velocity 1 plus this added change in velocity, whatever that is. Distance is still 1 mile. And distance 2 equals 1 mile. And time 2. What is the time? I'm going to write that down at the bottom here. All right. Time for scenario 2 equals time 1, or just time, plus the change in time, right? Plus a change in time. Now you might say, well, why don't you call that a minus a change in time, because it's actually less time. I'm going to keep a plus right there for now. All right, our change in time I'm actually going to write down to be negative, and we'll do that actually right now. Okay, so let's go to red and write down our givens, our knowns. Actually, our g's, our u's, and our e's. Right, our givens, our unknowns, and our equations. So given distance 1 equals 1 mile. Okay. Velocity 1, that's our unknown, that's what we're solving for, right? Time 1 equals just t, okay? Let's look at scenario 2. Distance 2 equals 1 mile. That's a similarity between these two scenarios, so that's going to be our link between scenario 1 and scenario 2, so keep that kind of in the back of your mind there. Velocity 2. We don't know what it is, but we know that it is velocity 1 plus the change in velocity. And time 2 equals time 1, or time, just call it t for time, all right? Because since that's equal to that, it's equal to that. We'll just call it t, keep it simple. T plus our change in time. Okay? All right, now let's write down some of the things that we actually do know. What is the change in time? Or let's go with the change in velocity, this right here. All right, what is the change in velocity between part 1 and part 2? The change in velocity is 7.9 miles per hour, right? 7.9 miles per hour. That's going to come in handy. Also, our time, our change in time. Our change in time between 1 and 2 is actually less, right? It goes down by 13 seconds. It's minus 13 seconds. So that's our change in time. Now you can't have a minus amount of time, but this is a difference in time increments, you might say. So we can put a minus in here and be okay with it. Okay. It is a difference, as it were. Now, what's wrong with that? Well, we got this in miles per hour, and this is in miles. This should probably be in hours, right? So let's go ahead and convert that minus 13 seconds to minus something hours. And if you do your factor label, and I'm going to do it just kind of the quick method right here, I get minus 3.6 times 10 to the negative third hours. All right, that's going to be our increment of our change in time between scenario 1 and scenario 2. All right, still with me? All right, so we got our givens, we got our unknowns right here. Let's write our equations down. Let's write this in blue. All right, our equation. What's our guiding equation? What are the three things that we're dealing with right here? Well, distance, velocity, and time, right? So if you know the increments of measurement for velocity, velocity is distance or length over time, right? So velocity equals distance over time. Now, we're going to have to do some substituting later on, and I'm just kind of giving you a heads up that's the case right here. And I'm going to leave some space down below. Well, actually, I'm going to fill it right now, all right? What I'm going to do is this is our fundamental equation. Velocity is a distance over time, miles per hour or meters per second, something like that. Let's go ahead and turn this around a couple different ways, all right? We can say that from that base equation, distance equals velocity times time, right? And we can also say time equals distance over velocity. All those are true. They're just rearrangements of the original base equation, okay? All right, now it's time to actually set up and solve for V1, all right? What is the one thing that links these two together, these two scenarios right here? And I'm going to change to green to actually solve for it. All right. What's the one thing that is similar between them, or the same? The distance, right? We can say the distance 1. Ooh, that's a really, really light green. It's probably kind of hard to see, so I'm going to make that a little bit darker, maybe. Do that right there. Distance 1 equals distance 2. Okay. Now, you may know what that is. You might say, oh, great, that's 1 mile. 1 mile equals 1 mile. Oh, that's brilliant. Well, yes. That's true, but remember, we rearranged some equations down here. What we can do in order to solve for that unknown V initial is that we can turn this around. We can look at this right here. We have a statement about distance in terms of velocity and time, so that we can say that velocity 1 times time, it's a time sign right there, it looks like a dot of the I, times time 1 equals velocity 2 times time 2. All right, you with me? That's all coming from the assumption that what is equal between them is the amount of distance. So we're rewriting the equation in terms of, we're substituting in Vt for d right there on both sides. Okay. V1 T1 equals V2 T2. That makes sense? All right. Now let's start substituting or writing these in a little bit more detail. All right. So let's write this first one, V1. That's what we're solving for, right? So that should make sense. Times T1. Keep that all the same right there because they're just unknowns. Equals, all right, so what is V2 right here? We said V2 is going to be V1 plus the change in V, the change in velocity, right? So let's go ahead and write that down. And I'm going to put it in brackets right there so we know that it's all V2. So V2 is V1 plus however much faster you're going, plus that change in velocity, which we are told what that is, okay? Times that T2, all right? What is a T2? Well, we can write that in more detail as well. That T2 right there, we can write as T1, or T, plus the change in time, all right? So that's going to be T1 plus, it's a plus sign right there, plus a change in time, and that's our T2. That coincides with that right there. Okay? Okay. Well, we can actually start rearranging this a little bit and kind of doing some algebra to clean this up a little bit, because we've got a v. Well, let's look and see what we have actually. First of all, this delta t, that change in time, that's a known, right? This is also a known, but unfortunately what is not a known is the v1 that we're solving for, right? But also this t1 right here, we don't know what that is. What is t1? Well, it's just t, time t. That doesn't help us. It's just some variable right there. What is that? Well, what we're going to do is we're going to start taking this and trying to rearrange it so that we can actually substitute something else in for t1 right there and solve for nothing other than the v1. All right? I'll show you what I mean in just a second. Okay, but first, let's get a couple less of these t1s right here. Here's what I mean. I'm going to go back to green. I'm going to take these two statements in brackets and I'm going to combine them. All right, these two we call polynomials. All right, so I'm going to multiply the first by the first, and then the first by the second, and then the second by the first, and the second by the second. Remember how to do that? Okay, so we're going to get v1 t1 equals, all right, so that times that, that's going to be v1 t1, first of all, right? So then we're going to go v1 times that, so that's plus v1 times a change in time. Now I'm going to do the second two. I'm going to go delta v times t1, right? Delta v times t1 plus the final two, delta v times delta t, plus delta v times delta t. I told you we're going to try to simplify this. You're saying, well, this looks even more complex than it was previously. It does, but it's going to get simpler because we can all of a sudden start canceling some stuff out. Look at this right here. So this is the same thing on that side, so we can actually both cancel those to 0. I'll draw a red line through them, so they go away. So now we have a simpler statement that says v1 delta t plus delta v times t1 plus delta v times delta t all equals what? Well, this canceled out right here, so that just became equals 0. Okay, equals 0. So, we still have the problem of, okay, we know, I'm sorry, this is, yeah, I'm sorry, I'm getting ahead of myself. This is a known, that's a known, okay? That's a known, and that's a known, that's good. But the problem is we've got two unknowns, v1 and t1. How do we solve an equation with two unknowns? Well, here's where the substitution part comes in. You can substitute something in here that is this in terms of that. Here's what I mean. Look down here in our lower left. Didn't we say that time is distance over velocity? After all, this is our guiding equation. Velocity is distance over time. Then we must be able to say that time is distance over velocity. So why don't we take this right here, distance over velocity, and stick that in for time 1. This could be time 1, time 2, time anything. We're going to rewrite it like this. I'll show you what I mean. v1 times delta t. All right. In fact, I'm going to write this smaller because I'm going to run out of space if I don't. v1 delta t plus, all right, we're going to take this and stick that in for t1 right there. All right, plus delta v times the fraction d1 over v1, right, equals t1, right, plus delta v times delta t equals 0. Okay? All right, now we've taken this unknown and actually turned it into, well, we know what d1 is, right? That's 1 mile, right? And we've created this slightly more complex fraction right here, but it makes things actually easier because we now only have one unknown. We know that, we know that, we know that, that, and that. The only thing we don't know is this v1, and if we can just combine those two, we can solve for v1, which is really what the whole problem is solving for. Okay? So what are we going to do? How are we going to actually solve or combine those two right here? The only way to get this v1 out of the denominator is just to multiply everything across the top by v1. So if I multiply that times v1, and this times v1, and this times v1 right here, it'll cause the numerator and denominator to cancel out, but then we'll have some other v1s over here, but that's okay. So this is going to turn out to be v1 squared times delta t plus, remember these, that and that cancels out, the top and the bottom right there, so plus delta V times D, 1 I should say, plus, all right, so we got this over here multiplied by V1 as well, so that's going to be V1 times delta V and delta T, all equals 0. All right, so we still don't have V1 in one place, but that's okay, because look at this pattern that we should recognize right here. Something something squared plus something something plus something else equals 0. I guess I said too many somethings right there. Look at the V1s. We've got it squared here, and we have it as a first order plus some other constant right here. What kind of an equation is this? It's a quadratic. It's a quadratic. Let's put it in standard quadratic form. All right. I'm going to put for example, this right here. We have ax squared, right? Or there's a coefficient. The a coefficient is out in front of the x squared. So I'm going to put the delta t in front of the vi squared right there. So delta t times vi squared, right? Plus, we're looking for a single order v now, right? So that's going to be that. Plus, the coefficient is going to be delta v times delta t times vi. Okay? Plus, here's just our constant right here. That's our c value. Plus delta v times d1 equals 0. That just simplified us for it greatly. You might think, why? There's still this long, crazy quadratic equation right here. Well, because we can just drop things into the a, the b, and the c values. This right here, this delta t, that's your a, all right? This right here is your b value, and this right here is your c value. The good news is those are all constants. That's a constant. That times that is a constant, and that times that is a constant. So we just get out our quad form program or app or calculator or wherever you have it, and you just key in your values. I'm not actually going to do it for you right now because I know you can do it. All right, but go over to our knowns right here. Key in for A what delta t is. Be careful because delta t was actually a negative, right? Key in for B, delta v times delta t. Still remembering that delta t is negative right there. And for C, key in delta v times our distance d. That should give you two answers, one of which is not real, the other which should be your right answer for that initial velocity right there. So this is a practice doing a lot of things. Practicing the guess method, practicing the substitution, also practicing using the quad form to solve for quadratic equations. All right, so if you have any questions, please let me know. But in the meantime, I hope that helps. And come see me if you have any questions. Thank you very much. I'll see you in the next one.